All right. So first of all, what is, you guys see the topic of the front, matrices. So what is a matrix? All right, other than the movies that you probably see. A matrix, it's a arranged set of numbers. And the way we arrange them is by rows and columns. And then we put a big brackets. We put brackets around the columns and rows. All right. We are not going to do this today, but here's what a matrix is used for. You guys remember last unit and probably last year in Algebra 2A, solving 3 equations, 3 variables, right? Do it, eliminate a variable, eliminate another one. Well, we can use a matrix to solve them too. Not today. Very end of the unit, we'll start doing that. All I want right now first is I'll give you the 3 equations and 3 variables. Let's design a matrix that shows that those 3 equations exist. All right, so first here, 1A, write a matrix for these systems. First thing, you got your big brackets around. Inside, we're going to fill it up with numbers that are in rows and columns. Where do I get those numbers from to fill it in? The equations. It's the numbers out in front of all the variables. So take that first equation here with me. 2x plus y plus 2z equals 2. I don't want variables in the matrix. I want the coefficients, the numbers in front. So row 1, row. And I'm serious here, no funny business. We all know the difference between a row versus a column. I start teaching this every year, and then all of a sudden the kid's like, wait, row, column. Rows go this way, columns go up and down, okay? So in the first row is my first equation. 2 from 2x. I don't put the variables, I just put the coefficients, the numbers out in front. 1 from 1y, and 2 from 2z. Equal signs do not go in a matrix. Instead, you're going to see a vertical line, which says, all right, stop. There's your equals. And then on the other side, 2. So that's how I write that equation into a matrix, using numbers only. All right, keep grinding. Next one, same matrix. Now this is going to be row 2 now. 3, -5, -1, and then on the other side, 4. And then you guys are probably picking it up now what row 3 is going to look like. 1, -2, -3, and -6. And some of you may be thinking, how in the world would you solve for X, Y, and Z with that thing there? Well, we'll get to it later on in the unit. I just want you to design them now. Questions? All right, couple hiccups. There's a couple wrinkles I could throw in here. Take a look at B. All right, new matrix, new brackets. Ready for row 1? 5, -2, -3, vertical bar, 0. All right, now I start throwing in a couple tricks, but I think you guys would figure it out. Look, next one is x plus y equals 5. So 1 for x, 1 for y, but I got to fill it in. I can't leave it blank. 0, correct. If we see a 0, that means that variable does not exist for that equation. And then 5. And then row 3. 2. There's no y, correct? 0, -3, and 4. So the rows are the equation, the columns are the variables. All right, rows are the equation, columns are the variables. Any issues? All right, I just want to make sure you can now take it out of a matrix. So here's your matrix. Can you guys help me write the equations they came from using x, y, and z as your variables? So first equation, 5x. Everyone sees there's no y?
Yeah.
Plus 3z equals -11. No x on the second one, but y minus 4z equals 12. And then the final one, you just have what? 7x and 2y equals 4, no z. And I'm not asking you, just write them. That's the great thing about day one here. I just want you to write them. We're not solving a darn thing today. All right, any questions? Putting it into a matrix or taking it out before I go on to the next piece here? All right. Next, you got to tell me how large it is now. Okay, how large a matrix is, what the size is. And instead of using the word size, we use the word order. Okay, order just tells me how big is the matrix. And how do you tell me how big? Row first, column second, and get in that habit for a lot of things in this unit. Number of rows come first, number of columns come second. So take a look at my example up here of this matrix. How many rows? Again, rows going left to right. 1, 2, 3. And that's not a multiplication symbol, that's by. All right, 3 by how many columns? 1, 2, 3, 4. So we would say this is a 3 by 4 matrix. 3 by 4. 3 rows, 4 columns. Again, rows always come first. Rows by column. All right, I got the number generator ready to roll. I know you're excited, so let's look at, flip the page over, and let's look at these 4 different matrices. How big are they? What is the order of each of them? So letter A, take a look. Row by column. Yeah, row by column. How big is this one? 15?
2 by 4.
There you go, 2 by 4. 2 rows, 4 columns. Good. Are we good? All right, what about matrix B? What's the size of that one? 12? I'm going to be here a while, I believe. 12, yeah, good talk today. 14? How about 9?
B, you said?
Part matrix B.
2 by 2.
That's a 2 by 2. Now look, I know C looks totally different than anything I've shown you today. Follow the rule. How many rows by how many columns? 11?
1 by 4.
1 by 4. 1 row, 4 columns. Good. And then, yeah, D is a matrix, by the way. That's a matrix. Just got a single number in there, but it's still what size then? 2? 1 by 1. Okay, 1 by 1. Okay. Everyone good with how to determine the size? All right. Last thing I have to show you today is how do you tell where a number is in the matrix? Like here, 66. Where is that in the matrix? I need a location. It's called an address. Nice, huh? It's where it lives in the matrix. All right, so everyone, take a look at this one specifically for me. All right, take a look at this one specifically. We're going to start naming the matrix. So this is matrix A. All right, matrix A. And we want to know A, matrix from matrix A, where 2, 3. What lives at 2, 3? Again, that's not 23. Hey, be careful. That's not 23. That's 2, 3. And remember how we name it. Row, column. Row 2, column 3. And if you need to get adjusted to it, don't be scared to do this. Row 2, column 3, and see where your intersection is. All right, before you start picking it up. That's totally all right. Don't be afraid to do that. So we see row 2, column 3. The number 1 lives there. Okay, so that's how we name a specific location in the matrix. All right, help me find a couple locations here for matrix D. On the next page, matrix D. What lives at 2, 2? What lives at 2, 2? Address at 2, 2. What lives there? Let's go 9. I don't think so. I'll do this. 1. Amanda. 4. Good work. Row 2, column 2. Okay, guys, circle it if you have to. Who cares? 3, 1. What lives at 3, 1? Row, column. 3.
0.
0. Good, Dylan. Nice. What lives at 1, 1? 14. 13.
Negative.
Oh, sorry, Jay.
-1.
-1. What lives at 2, 3?
0.
No.
3, 4, 6, 2.
What's the 2? Tell me.
Row 2.
Row 2. What's the 3? Tell me.
Column 3.
But what's
0.
not there? There is no column 3. So this is not possible. All right, I threw that one out. I don't want to say 0 because 0 is a number. It's not possible. All right, just trying to throw that one out there. That's not possible. 2, 3. There's no column 3. So there's no way I can give you a number. All right? All right, I'll give you 2, 3 minutes right now. Go ahead and do the in-class examples on your own, see what you got, and then I'll throw the answers up. And that's all we got for today. Again, taking it slow. So go ahead, try those in-class examples out right now. Okay, here you go. Here's the first page. Everyone's all good? And then I'm hoping everybody went XWZ or XYZW. I had originally gone in alphabetical order, but last period was like, no, go in the order it has up there. So that's rewrote it. Any issues there? Again, please don't be a hero and do the Delta Math outside it. It's a class assignment for tomorrow, so please wait till tomorrow to do it. And yeah, that's it for today. We're going slow here.